Okay, guys, in this video, I'm going to do 5 questions where we're going to do some work with linear equations, but ultimately do our best to solve these world problems, applications, and modeling with these linear equations. So I have some steps here, some guides, or some checks, I guess, to help you with the process of doing this. But ultimately, the idea is that do your best to write things out, define a variable, see if you can write an equation that connects the variable to something else, and then ultimately, does your answer sound reasonable? Okay, so the first one, it says, if the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. All right, so there's a lot going on there. So my brain first just thought, okay, so we have a square, and this is the original square with side S. All right, and what they've done is they've taken each side of the square and increased it by 3 centimeters. So I'm going to first write, let S represent the original square side length. Okay, that's the first thing I'm going to do. So the perimeter of the new square, if each of these sides is going to increase by 3 centimeters, is I take the side, add 3 centimeters, and then multiply by 4. You could write s plus 3 plus s plus 3 plus s plus 3 plus s plus 3, but ultimately repeated addition is multiplication. So I'm going to do 4 times s plus 3. Now later in the problem, it says that the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. So now I know that this perimeter of the new square is going to be 4 times our original side length plus 3. That's going to be equal to 40 more than twice, so 2 times the length of the original side of the square, so 2s. All right, and those have to be equal to each other. So from here, I'm ready to actually solve for s. So I'm going to distribute the 4. All right, and then I'm going to move the 2s to the left to get 2s. I'm going to move the 12 to the other side to get 28. All right, and then from there, I'm going to get s is equal to 14. All right, so the original square has side lengths of 14 centimeters. So I'm going to say the dimensions of the original square is the side is 14 centimeters. All right, so that's it for the first one. Let's go to example 2. We have Jorge, who is leaving his house, traveling 2 miles an hour. Okay? Nadine leaves 6 hours later. And to catch up with him, hoping to do that at some point, traveling 8 miles per hour. How long will it take her to catch up with him? Okay? Excuse me. So I'm going to let T represent the time, so this is in hours, that it takes Nadine to catch up with Jorge after she starts. All right, so essentially I'm trying to figure out what T is equal to. All right, so now what I'm going to do is I need to write an equation. So it says during this time, Nadine is traveling at 8 miles per hour, and Jorge has already been traveling for T plus 6 hours at 2 miles per hour. So what I'm going to do is I'm going to write the distance that each one has traveled. So this is the distance that Jorge has traveled, and then the distance that Nadine is traveling. Okay, so to do the distance, we're going to do their miles per hour, so that's their rate, times the time, so how many hours have they been moving, and if I multiply those two together, that will give me the distance. So for Jorge, he's moving, his rate is 2 miles an hour. So I'm going to multiply that by the time that he has been moving. And in this case, that time is T plus 6. Remember, T represents the time that it takes Nadine to catch up with Jorge after she starts. All right, and he has a 6 hour head start. So that's where the plus 6 comes from. And then Nadine travels at 8 miles per hour. That's her rate, times the time, which is t. Okay? And I know that I'm trying to figure out at what point are these distances going to be the same. Okay? So I'm going to set them equal to each other. So I'm going to distribute the 2. Get 2t plus 12 is equal to 8t. Move the 2t to the other side, and you get 6t equals 12, or t equals 2. So essentially, what we're saying here is that it's going to take Nadine 2 hours to catch up with Jorge if she's traveling at 8 miles per hour. So it will take 2 hours. Okay? All right, let's go to example 3. Example 3. A chemist needs a 20% solution of alcohol. She has a 15% solution on hand, as well as a 30% solution. How many liters of the 15% solution should she add to 3 liters of the 30% solution to obtain the 20% solution? So essentially, we need to dilute the 30% solution, right, by adding the 15% one to get the correct percentage solution of alcohol to be 20%, okay? So I'm going to let X, and you could use any letter, represent the number of liters of the 15% solution the chemist will add to the 3 liters of the 30% solution. All right, so essentially if I solve for this, I'll have the answer that I need for this example. Okay, now we know that the amount of alcohol in each solution is obtained by multiplying the volume of the percentage of alcohol in the solution. So if we know the volume of our container and we know the percentage of alcohol, we can multiply those together and that will give us the amount of alcohol. All right, so in the first one, so in the 15% solution, we're going to multiply X liters. Remember, I don't know, right? That's ultimately what this represents, times 0.15. All right, so by doing that, we can say that this is 0.15x liters. For the other one, the 30% solution, we have 3 liters. We know that it's 3 liters times the percentage for that solution, which is 0.3. So if we multiply that, we get 0.9 liters. All right, and remember, this is the amount of alcohol that's in that 3-liter solution. Total amount of alcohol that is resulting for the solution would be X plus 3 liters, right? Because ultimately, we're starting at 3, right? We started here, and we've got to add the 15% solution until we get some amount that's going to give us 20% solution. So in terms of how much total amount of alcohol will be in there, we're going to add X plus 3 liters. Okay? And the amount of solution in that one, let me organize it like this. I'll do it over here. No, I'll do it. I can go. So X plus 3 times that percentage, right? This is the one we're trying to obtain, would be 0.2. All right? And ultimately, what we're trying to say is that these two, this one and this one, when you add them together, we're hoping to get this one here. So I'm going to set those equal to each other, all right? And then I'm going to solve. So I have 0.15x plus 0.9 is equal to 0.2 times x plus 3. So if those are the same, if they're true, then we are going to find the value for x. So how many liters of the 15% we need to pour in to dilute the 30% to become a 20% solution. Okay, so leave the left side alone. Multiply the right side. You get 0.2x plus 0.6. Move the I'm going to actually move the 0.15x over to get 0.05x. Move the 0.6 to the other side and get 0.3. Now, you guys would have done this even last year with your geometry. I know we're doing it right now in my geometry class. If you wanted to multiply everything by 100, you would get 5x equals 3. But you don't have to, right? You can just use this. We're just going to divide both sides by 0.05. So if you divide both sides, you get 5x equals 30. Apologize. If you divide both sides by 0.05, right, you can just do 30 divided by 5, which is 6. So essentially what we're saying is we need to add 6 liters. So 6 liters of the 15% solution. If we add that to our 3 liters of 30% solution, that would give us those 9 liters of a 20% solution. All right, let's do the next one, number 4. 2 more to go. We've got Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Eduardo because he lives 40 miles farther away. Eduardo travels 5 miles an hour faster than Maria. Find their average rates. Okay, so I'm gonna first do Maria's average speed is represented by, and I'm gonna use R miles per hour. R miles per hour. Okay, and we're saying that Eduardo is traveling 5 miles an hour faster than Maria. So I'm going to say Eduardo's average speed is going to be R plus 5 miles per hour. Okay, now it takes Maria 2 hours. All right, so I'm going to say for the distance, when we did this before, I think in example 2. Yes, example 2. Distance is the rate times time. So we have Maria's rate or speed is R. So this is distance. Let's say Maria. Right? I'm going to do R for her rate and then times 2 because she's doing 2 hours. So 2 hours times her rate, her average rate would give us the distance she's traveling. The distance for Eduardo is he is traveling for 2.5 hours, right? That's how long he's traveling. And his average rate is Maria's rate, but plus 5, because it says in the problem that he travels 5 miles an hour faster than her. Okay? So we're essentially saying that if we have this here, right, we need to make sure that we set up an equation. But the one thing I haven't mentioned yet is that Eduardo lives 40 miles farther away. Okay? So we have to set up the following equation that if we're doing Maria's distance plus that 40 miles, right, because we need to make those the same, equals the distance Eduardo is traveling. All right, so that's the one piece that some students might forget. Okay, go ahead and distribute. On the right side, you get 2.5 times R plus, that's going to be, I think 12.5. I believe that's right. Yes, it is. Go ahead and move. I'm going to move the 2R over to get 0.5 R. Move the 12.5 over to get, what is that? It's going to be 27.5, I believe. And when you do 27.5 divided by 0.5, you're really multiplying by 2. So 27.5 times 2 is going to give us 55. All right, so that is Maria's average speed. All right, now it does say to find both of their average rates. So remember, this is Maria's average rate is 55 miles per hour. And so since Eduardo is traveling 5 miles an hour faster, Eduardo's average rate is going to be 60 miles an hour. Okay? All right, last one. We have an artist has sold a painting for $410,000. Whew, that's a lot of money. He invests a portion of the money for 6 months at 2.65% and the rest for a year at 2.91%. His broker tells him the two investments will earn a total of $8,761. How much should be invested at each rate to obtain that amount of investment? Okay, so I'm going to first let X represent the amount invested at the 2.65% rate for 6 months. And then whatever that is, I'm going to do 410,000 minus that, right? Because whatever we choose for that amount, the rest is going to go into this other one. right, represent the amount invested at 2.91%, and that we said in the problem was for 1 year. Okay? All right. So now we need to calculate that interest earned on each. Okay? So for the 6-month investment at 2.65%, we're going to calculate the interest using a formula called principal times rate times time. All right, so this is a formula I don't know if you've seen yet, but you write it as capital P times lowercase r times, times lowercase t, and that capital I is interest. All right, so you can always, this is called a simple interest formula. All right, I'm not too concerned if you overwhelm with this. You're gonna plenty of time to get used to this, don't worry. And so for 6 months, for that particular investment at the 2.65, so this is for the 2.65% investment, the interest is going to be equal to whatever principal we choose, which we're saying is X, times the rate, 0.0265, right? So move the decimal over. And then I'm going to use times 0.5 because they said 6 months, right? And it said, where did it say? 6 months, which is half a year. Okay, so that's why I use 0.5. So whatever that is, right, that's going to be our simple interest. For the 2.91% simple interest, we're multiplying 410,000 minus X, right? That's our principal, how much we're investing, times the rate of 0.0291. And then this was just times 1 because we're doing 1 year in that investment. Okay. Now we know the total interest earned, right? They gave us that amount. They told us the total interest earned is $8,761 for the 2 investments. So what I'm going to do is take each of these that are separate right now. So take the 0.5 times 0.0265 times X plus the 410,000 minus X times 0.021. I hope you're okay if I just leave off the times 1. And whatever that is has to be equal to $8,761. I know there's a lot going on here, but we have only one unknown, so we can absolutely solve for this value for X. So the first thing I'm going to do is multiply the 0.5 times the 0.0625. 0.0265. Oops, said backwards. Fine. The 0.5 times 0.0265, which is 0.01325. So that's 0.01325x plus, do some multiplying here. I'm going to multiply that 410,000 times 0.0291, which is $11,931 minus 0.0291x, and leave the right side the same. I'm going to combine like terms with this 0.01325 minus 0.0291, so 0.01325 minus 0.0291 gives me negative 0.01585x. Move the 11,000 over, and it's okay that we have a negative number when we move it over with minus because our number in front of our constant is negative, so negative 3,170. And if I divide both sides by that negative 0.01585, that will give me the amount we're investing. So X ends up being $200,000. So we're saying we're investing $200,000 into that 6 months one, so into the 2.65% investment. And then if we do 410,000 minus that, that gives us 210,000, the rest of it into the other one, which is 2.91%. I know I ran out of room there, but ultimately that's how you do that one. All right, guys, I know this is a lot. Try the homework, and we'll talk about the rest of it in class. Good luck.